This is the application that I will be writing in this tutorial. So let's say the target solution is this, and the chromosome population size maybe is 10, and for the purpose of this tutorial, let's say this is crossover rate, and this is the probability that two chromosomes will create another chromosome with genes coming from each one of the parent chromosomes, and the range is between 0 and 1. And for mutation rate, the range is also between 0 and 1. Let's say it's 0.25 for the purpose of this tutorial. And this is the probability that a chromosome genes will do random mutation. So the number of elite chromosomes that will not be subjected to crossover or mutation from one generation to the next. Let's say this is 1, and the tournament population size, and this is used for chromosome crossover selection. Let's say it's maybe 3, and let's go ahead and try it. So we went from generation 0 to generation 10, and here we have 13 genes, and this is exactly the same as this one. So they are sorted. The population here is sorted in each one of the generations. So maybe let's change this chromosome and make the population to be maybe 12, and let's try it again. So here we go, we went from generation 0 to generation 9. Next we will be writing the code step by step. So we will have a chromosome class representing a potential solution, and it will be in this package, and a population class representing a population of potential solutions, and a genetic algorithm, and a JavaFX driver class where all the JavaFX code will be, and where we will have a main method. Now the genetic algorithm will have a constructor with values coming from the JavaFX driver class. So let me define those here, and we will be setting them in the constructor. And let's have this get method that will return this target solution, a target chromosome. And now going to the chromosome class, we will have a constructor that takes in a genetic algorithm, and let's define this genes array of ints, and we will be instantiating it in the constructor and setting its length based on the length of the target chromosome. And let me define this genetic algorithm. and I will be setting it here in the constructor. And let me define this initialize chromosome method that will initialize this chromosome with random genes. So if mass.random bigger than 0, bigger or equal to 0.5, then put 1 for this gene, otherwise we put 0. We have a for loop, and for convenience we're returning this chromosome. And let's define this fitness, and a flag is fitness changed, and we'll set it initially to true. And let me define this recalculate fitness method that will calculate the fitness of this chromosome by comparing it to the target chromosome. So each gene to the gene and the target chromosome, and depending on that we add 1 to the fitness. And let's have the toString method return the genes in the genes array. So this dot genes, and the get fitness method will return the fitness, but first it checks the is fitness changed flag, and if it is, it will recalculate the fitness and set that flag to false. And the get genes method will return the genes. So this should do it for the chromosome class. Next, let's go to the population class. Here we will have a constructor with the population size coming from the JavaFX UI, and this chromosome population will have an array of chromosomes which will be instantiated in the constructor, and its size is the population size. And let me define also this genetic algorithm instance variable, and we will also be setting it in the constructor. And let's have a get method for this chromosome array. And a sort chromosome by fitness that uses Java 8 to sort those chromosomes in this array. And lastly, we need an initialize population method that will initialize all the chromosomes in this population. So we have a for loop, and we're instantiating chromosomes and calling the initialize chromosome method on them. And then we sort those chromosomes, and for convenience return this population. And this should do it for this class. So next, let's go to the genetic algorithm class. Now here, to apply crossover to the population, we will have this crossover population method. Let's for now return null. And for applying mutation to the population, we'll have this mutate population method. And for now we will return null also. And I will have a public evolve method with the population, with the current population passed in, and here we will call crossover population, and the population that's returned from that we will call the mutate population on it, and we will return what's returned from that method. And we will be using tournament selection to select chromosomes for crossover. Let's return null for now, and I will have this crossover chromosome method that will be called in a loop from the crossover population. And same thing, we'll have this mutate chromosome method that will also be called in a loop from the mutate population method. Now in crossover population, we will instantiate a new population and return it, and we will copy the elite chromosomes as is to the new population. As for the remaining chromosomes in the old population, we will only do crossover between two chromosomes if mass.random is smaller or equal to the crossover rate. So let's define chromosome 1 and chromosome 2, and we will pick up each one using tournament selection. So we'll call this select tournament population method, and we'll pick the one with the highest fitness in both cases, and then we will call this crossover chromosome method with those two chromosomes. And if we're not gonna do crossover, then we will just call the select tournament population and pick up the chromosome with the highest fitness without calling this method. Next, let's code those two methods, this one and this one, since we just mentioned them. So we'll instantiate a new population with the size being the tournament selection size from the UI, and we will end up returning this population. But first we will populate it. So we will loop from 0 to the tournament selection size, and we will populate this population, this tournament population, from the old population based on a tournament selection. So mass.random times population.get chromosomes.length. And before returning this, we will call the sort chromosomes by fitness. And here we will instantiate a new chromosome and return it. And each gene in this new chromosome will be either coming from chromosome 1 or chromosome 2. Now in the mutate population method, we will instantiate a new population and copy the elite chromosomes as is to this new population. As for the rest of the chromosomes in the old population, we will loop through them and call the mutate chromosome method on them, and populate this new population and return it. And next, let's do this mutate chromosome method. So we'll instantiate a new chromosome and return it. But before that, we will loop through all the genes in the passed in chromosome, and if mass.random is smaller or equal to the mutation rate, then we'll perform mutation. Otherwise, we will move the gene as is to the mutate chromosome, and the mutated chromosome will have either 1 or 0, depending on if mass.random is smaller to 0.5 or not. So this should do it for this class. Next we will do the driver class. This is a JavaFX application, so it has to extend from application. And let me go here to project properties, and let's remove this one and add library. And yes, this is the full JDK, so let's use it. And by extending from application, we have to implement this method. Now all what we will do in main is to call launch, which will end up triggering a call to the start method. And let's define those widgets. And initialize them in this method. And the target gene will be entered as a string by the user, so I have to turn it into an array. So this Java 8 method does that. It returns an int array, and I will have this method that will print the chromosome population inside the text area, so print population. And what remains is the start method. So I will initially call the initialize controls, passing in the primary stage, and after writing the logic, I'll do primary stage dot show. Now clicking the send button will trigger the logic of this genetic algorithm. So let me define those two up here, population and the genetic algorithm, and I'll instantiate the genetic algorithm here with the values that are passed in from what the user entered. So we have the target solution and the crossover rate and the mutation rate and the number of elite chromosomes, and the tournament selection size. And we'll do platform.run later. In order to update the GUI from a non-GUI thread, and this would put the update in a queue and will be handled by the UI thread as soon as possible. So I will first clear the text area, and then initialize the population and append the population 0 information to the text area. So generation 0 and the fittest chromosome fitness. And I will print that population using this method we wrote here. And I will have the code that evolves the population in this while loop. So let's define this generation number here, and increase the generation number counter. And evolve the population by calling genetic algorithm.evolve, passing in the old population, and this would be the evolved population. Then I will sort the chromosomes in this population by fitness, and add this to the text area. So the generation number and the fittest chromosome fitness, and we will print that population. And this should do it. Next, let's go ahead and test run this application. So let's say this is the target chromosome. Population size, let's say it's 7. Crossover rate, let's say it's 0.75, and this should be between 0 and 1, and mutation rate, let's make it 0.25. So same thing, this should be between 0 and 1. Number of elite chromosomes, let's go for 1. Tournament size, let's say it's 2. Let's run it. So we went from generation 0, where this is the highest fitness, 7. So we have 7 of these genes are the same as the target chromosome genes. And we went to generation 27, and here those are exactly the same as those genes.